Alrighty, what is up, my physics nerds? We are going over the very first example of the new energy unit. We're starting out learning just how to calculate the work being done by a force. Alright, so remember, any force can do work on an object. So we want to calculate the work done by a single force. So in this problem, we have Herman pushes his fridge across a flat floor, as one does. He moves the refrigerator 2 meters by applying a constant force of 200 newtons. How much work is done? So we are trying to find all of the work being done by Herman on the fridge. So the force we're worrying about is the applied force by Herman on the fridge. All right. So we know our work equation. If we take a look at our equation sheet right here and go to the backside, you can see that the work equation right here, the change of energy is equal to work, which is equal to the force being applied that's parallel to the distance that the thing's moving. All right, so when you work all that out, that comes out to FD cosine theta. So our equation for work is right here on the equation sheet. So we're actually going to use that now and calculate how much work is being done. So work is equal to force times the distance the thing moves times the cosine of theta. Now, if we take a look at this problem, we can kind of think there's the fridge, there's the person pushing it. That force they're applying is, let's say in this problem, it's to the right. And this thing is actually moving to the right also. So both of those vectors are pointing the exact same direction, which means that this is a cosine of 0. So when we plug all this in, we have a force of 200 newtons times a distance of 2 meters times the cosine of 0 degrees. And if you haven't done a little trig in a while, that's fine, but cosine of 0 degrees is 1. So it kind of just becomes invisible. All right, so our final answer would be a work of 200 times 2 is 400 newtons times meters. So 400 newton meters is our answer for work. A newton meter is totally fine as a unit. There is one other thing we want to address a little bit. So with units, 1 newton meter is equivalent to 1 joule. All right, so joules is kind of our new units for energy that we're going to be using this unit. So joule, for all you guys are all kind of like giggling to yourself, it is spelled differently than the current vaping thing that is going around. So 1 joule of energy is equivalent to 1 newton of force that's applied to something to move at a meter. All right. All right, I'll see you guys in class. Do you have any questions or anything else you want to see as a video, let me know in the comments, and I will see you later.